had to do question 3. So I basically took 2 and kind of switched it into the opposite direction. But the first thing that we're going to do is the same, but instead of looking at the vectors that we put in alpha, we're going to set up our equation using the vectors we get out of alpha. So we have 1, 0, 0 is equal to a of 1, 2, negative 1 plus b 0, 1, 1 plus c 3, 3, 3. So now we're going to set up a system of equations using this part. So we have 1 is equal to a plus 3c. We don't have a b because our first part of the second vector is 0, so there's no b. Our second equation we get is 0 equals 2a plus b plus 3c. And our last equation we get is 0 equals negative a plus b plus 3c. So the first thing that I did was I took the top equation and I solved for 3c. And I solved for 3c because each equation has the same 3c. And I thought that would make substituting way easier. So I got 3c is equal to 1 minus a. So then the second equation that I looked at was the third equation. I substituted in for 3c with the 1 minus a and got 0 equals negative a plus b plus 1 minus a. So then I got 0 equals negative 2a plus b plus 1. So then I got b equals positive 2a minus 1. And then I took both the 3c and the b, substituted them into the third equation. Let me highlight what goes with what. And I plugged both of those into the green middle equation. So I got 0 equals 2a plus 2a minus 1 plus 1 minus a. So 2a plus 2a minus a gave me 3a. And then the negative 1 and 1 cancel each other out, so I got a is equal to 0. And now I took that a and just plugged into the other equations to figure out what those equaled. So if I take that a and plug into the blue equation for b, I got b equals negative 1. And then I took that a equals to 0, plugged it in here into my orange equation, and got c equals 1/3. So after now that I found my a, b, and c, I took the original equation, kept 1, 0, 0, but now replaced our parts. I kept my a for right now, but I replaced it with the alphas. So alpha 1, 1, 0 gave you 1, 2, negative 1, plus b alpha 1, 0, negative 1, and c alpha of 0, negative 1, 1. So this is when I really looked at 2 and thought, how can I make this the opposite of what we did for 2? So I thought to myself, well, I'm finding alpha of some vector. I don't know what that vector is, so I just called it x, y, z. Then I plugged in what I got for a, b, and c, so I got 0 times my alpha minus alpha plus 1/3 alpha. So now that I have this, I can set up little equations to figure out what my x, y, and z are. Let's do this color, and this color, sure. So I would say x equals 0 times 1 minus 1 plus 1/3 0. So I had x equals 0 times 1 minus 1 plus 1/3 0. These cancel out because of the zeros, so we're left with x equals -1. And then I did the same for the y. So I got y equals 0 times 1 minus 0 plus 1/3 times -1. These cancel out, so we're left with y equals -1/3. And then our last one, z 0 minus -1 plus 1/3 1. For this one, we only have the 0 zeros cancel out. So we have z equals 1 plus 1/3. So z equals 4/3. So now we can put this together that if I take alpha of a vector and I get 1, 0, 0 out, that vector would be -1, -1/3, and +4/3.